All right, welcome back to Mr. P House with Calculus. This is day 7 for Unit 0. And we're going to start off, we're going to be graphing rational functions in this video, and we're going to start by solving some rational functions. Now, when you look here, looking at the denominators, the first thing I notice is that these denominators can be factored because they both have a common factor of x. Same thing here. It's literally the exact same denominator, so that's x minus 1 right there. Now, you'll notice that all three denominators have a factor of x, but the middle one is missing the x minus 1. So multiply both the top and bottom by x minus 1. Now that all of them have the x times x minus 1, and since the denominators are all the same, then the numerators must also be equal to each other. So I'll just bring down that 1. So basically I can multiply all three of these, or both sides of the equation, by the same common denominator. So this brings down the 1 plus 1 times x minus 1 literally is x minus 1. Now I'll put it in parentheses even though technically that's not needed because it's this plus this equals 5. Now, the 1 and the negative 1, as I said, the parentheses aren't really protecting anything at this point. Can't do what's inside the parentheses first, so then it's gone. And then the 1 and the negative 1 cancels, and you're left with just x. And x equals 5 is your solution here. If you plug 5 in for x, it's the only answer that's going to work. All right, so now, once again, we are graphing rational functions, which means anything with a variable in the denominator. And we're going to be doing it by finding x and y intercepts and finding horizontal and vertical asymptotes. Now, this is the parent function, 1 over x, and I'm just going to use this for a first question to show you how exactly to do this. So, x-intercepts and y-intercepts, we covered that in the past video. So, all you have to do for an x-intercept is plug 0 in for y, and to find a y-intercept, put 0 in for x and solve. So, 0 equals 1 over x, multiply both sides by x. And you've got 0 equals 1. Now, that's not a true statement, obviously, so therefore, our x-intercept in this case is going to be at, there is going to be 1, so it's going to be undefined, sorry. It's going to be undefined because that doesn't make any sense. There's no x-intercept here because literally, as we'll find, the horizontal asymptote is the x-axis. Now, y-intercept, so we have y equals 1 over 0. Now, once again, that doesn't make any sense either because how can you divide 1 divided by 0? That's undefined also. So that also doesn't make sense. That also does make sense because the vertical asymptote is going to be on the y-axis. Now, to find the horizontal asymptote, which is the next thing that I'm going to do. So there's a couple of rules here for them, which I need to go over. So what you have to do is you have to look at the degree of the function. Now, degree just means the exponent, or greatest exponent, I should say, of the variable. Now, on the top, this is kind of like 1x to the 0th. So that's like 0 on top and a degree of 1 on bottom. So if the numerator's degree is less than the denominator's degree, then you know that it's going to be y equals 0. If the numerator's degree is greater than the denominator's degree, in this case, then you know it's not going to have one. It's not going to have a horizontal asymptote. And when the numerator's degree is equal to the denominator's degree, then what you would do is you would divide the coefficients. Divide coefficients, and that'll tell you, what it is. And I think that actually happens on one of the questions. I'll explain that when I get there. So this is when the numerator is less than the denominator, so that means it's always going to be y equals 0. So numerator is less than denominator's degree. Now, the degree of it just means the exponent. 0 is less than 1. For vertical asymptotes, what you're going to do, well, vertical asymptotes exist because the denominator, you can never have a denominator of 0 because you can never have anything divided by 0. So what you do is you take whatever the denominator is and you set it to 0, and that would be the vertical asymptote. Now, this is just the parent function. Now, what I could do next is I could take an x value and I would test it. So if I put in, for instance, something on the left side of the vertical asymptote, like -1, and something on the right side of the vertical asymptote, like +1, and I plug it in, 1 divided by -1 is -1. So I know it's going to be below. -1 will be a point. And if I put 1 in for x, 1 divided by 1 is 1. So if the x is 1, the y is 1. Now, what you're going to find is that you're going to start as close as you can to this asymptote, hit that point, and then go close to this asymptote. And what it looks like is that the two pieces for this function are going to be in the first and third quadrant. So what you're really trying to find out, because the domain for rationals will always be all real numbers, except what vertical asymptotes there may or may not be. And actually, it could be more than one vertical asymptote. In this case, there's only one, though. But the domain's all real numbers, and it always will be, except for the asymptotes. Or holes. That could also happen as well. So I just need to figure out if it's going to be on top or bottom in this case. And it's always going to start as close as you can to the asymptote and end as close as you can to an asymptote. And then it has that infinite discontinuity, which we'll talk about in the future. All right, so let's look at the next question. Now, you may remember back in Algebra 2 that this is really just a right one transformation. X minus 1 because it's x minus h plus k. And that's a left to right transformation. This is up or down transformation. All right, but I'm going to do it the other way like I just said. So finding the X-intercept and Y-intercept by putting 0 in for y, 1 over x minus 1. Now, the easy thing here is if I multiply both sides by x minus 1, if I multiply this side by x minus 1, and of course the pen's not working right here. Okay, so then I multiply this side by x minus 1. These will cancel out. Anything times 0 stays 0. So once again, we don't have an x-intercept. That doesn't really won't make any sense. Now, I like to do the horizontal vertical asymptotes first, to be honest, and then these kind of just make sense. So let's see, 0. I'm going to do that on the next one. I usually don't do the intercepts first. So for y-intercept, I'm going to make x 0. So y equals, I started that wrong. So that should be 1 over 0 minus 1. So y equals 1 over -1, which means y equals -1. So y equals -1. So, I'm sorry, x. Ugh, what am I doing? I knew something was up here. All right, so let's try this again. So the y-intercept means x is 0, right? Oh, I did just have it. All right, so this means our y-intercept will be 0, -1, like such. So 0, -1 is going to be right there. All right, so now our vertical and horizontal asymptote. So horizontal asymptote, remember, we look at the degree, and we see a degree of 0 on top and a degree of 1 on bottom. So therefore, this is going to be numerator. This is another case where the numerator is less than the denominator. So therefore, it's going to be y equals 0. So we know it's going to be right here. And now the vertical asymptotes, what you do is you take the denominators and set it equal to 0. X minus 1 equals 0. So then x equals 1. And that makes sense to what I said before because it's a right one transformation. Now, I could test it. I know it's going to hit that y-intercept right there. So I don't really need to test anything on the left side. For the sake of saving time, I'm just going to say that it is there, and that is where it is. And I just want to get to the next example because I'm already 8 minutes in. All right, so next question. So we have horizontal asymptote first. The top degree is greater than the bottom. So there is no horizontal asymptote. For vertical asymptotes, because the denominator greater than the numerator. So take the denominator, set it equal to 0, and that's going to be 1. So x equals 1. So once again, this is a right one transformation. All right, so it's x squared minus, so we have x-intercept and y-intercept. So x-intercept means y is 0. So we have x squared minus 1 over x minus 1. Now, if I multiply both sides by x minus 1, that's still going to give me, that's basically going to eliminate that out, right? Multiplying both sides by that. So x squared minus 1, that can be factored to x plus 1 times x minus 1, which then tells me that this is going to have two x-intercepts, one at -1 and one at +1. Now, +1 doesn't make any sense. We're going to cancel that out because and I know I'm sort of rushing here. I shouldn't have. But I need to go back over and talk about how this turns into this, and then we have a hole at x minus 1. And I just found that out because X-intercept can't exist on the asymptote. That wouldn't make any sense in this case. Actually, that can happen, believe it or not, but not in this case. So Y-intercept, we have 0 in for x and solve. So y equals, now I'm going to use the simplified version, so it's just x plus 1. Because the x minus 1's got canceled out. So this is the same thing as x plus 1. So that's 0 plus 1, which is 1. So y equals 1 would be right here. Sorry, dotted line. And then clearly this one is going to go like this. And what I would do is I would test it and find out whether or not this side is going to be on top or bottom by putting in 2. 2 plus 1 makes 3, so 2 is going to have a height of 3, so clearly this graph is going to be above the dotted line on the right-hand side. Alright, so 11 minutes in, hopefully I got time for at least one more here. So we have the top degree is only 1, the bottom degree is 2, so that tells us right there that it's going to be y equals 0, because the numerator's degree is smaller than the denominators. Now, this can be factored to x minus 3 times x minus 1, so I'm going to go ahead and do that. There is no hole on this question. There's nothing that can cancel out top and bottom. So vertical asymptotes, so horizontal asymptotes, we know top is less than bottom, so we know it's y equals 0. For vertical asymptotes, set both of your denominators equal to 0 and solve. So x looks like x equals 3 is 1 right here, and then also x equals 1, which is right here. All right, now x and y intercepts, if I plug X-intercept and Y-intercept, so if I plug 0 in for y, now the denominator is basically just going to cancel out, let's be honest. So x is at, because if I multiply both sides by the denominator, then the left side is still going to be 0 anyway, and the right side is going to cancel out. So x equals 0 is a right here. Okay, so this is that special case where we do have on the asymptotes. All right, now for the y-intercept, so we have y equals x, which is 0, 0 over 0 minus 3 is negative 3, and I'm sort of saving some time here. 0 minus 1 is negative 1, so plus 0 in for x, so I have 0 divided by 3, which is still 0, and there we go, so it's in the exact same place again. All right, now, what I would need to do at this point is I would need to test to find if the graph is above or below in this case. When you do the testing, I believe it ends up being here, and then here, and then here. Well, like I said, it's just a matter of picking a domain that's going to be in that section and seeing if it's going to be above or below. For instance, if I put negative 1 in for x, negative 1 minus 3 is negative 4. Negative 1 minus 1 is negative 2. All right, and negative 1 on top. So that's 8. So that's negative 1 over, okay, so I feel like I did something wrong. So I put negative 1 for x. So it's negative 1 on top. Negative 1 minus 3 is negative 4. Negative 1 minus 2 is negative 2. Okay, so that's 8. So that's negative 1/8. Negative 1/8 should have been below. Okay, so I guess I had it backwards. I guess it's the exact opposite of what I just did then. All right, so I only got 2 minutes left, or not even that, 1 minute left. So last one. First thing I would do is I would factor this. So this is x plus 3 times x plus 2. Now, with what time that I have left over, I want to talk about the fact that this is a hole, right, at x plus 2. So obviously, x equals negative 2 has a hole in it once I set it equal to 0 and solve. And if I plug it into the equation that I have left, I can figure out the height of that. So negative 2 plus 3 is 1. 1 over 1 is 1. So at x equals negative 2, it has a height of 1, and there's going to be the hole right there. The top's degree is less than the bottom, so that tells me that it's going to be a horizontal asymptote at 0. And I know I'm down to 30 seconds left, so I guess I'm just going to have to stop right there. Thanks again for watching, and have a wonderful day.